Okay, so we're going to be looking at similar polygons today. What similar polygons are is, suppose you have a polygon and you either stretch it or skew it to make it larger or smaller. It's still the same shape, but it's not completely congruent. So similar figures have the same shape, but not necessarily the same size. So we're going to use this symbol here to abbreviate for similar. So before we were using congruent where it had the squiggly line and the equals. Now you're just going to use the single squiggly line. It says if two polygons are similar, if the corresponding angles are congruent. So angles are still going to be congruent in this case. However, the lengths of the corresponding sides are proportional. So that's going to be where it's different. So the angles are still going to be the same in similar figures, but the lengths are going to be proportional. Okay, so if you look at this here, you'll notice that angle G, B and H, C and I, D and J are all congruent, but then you're going to look at the proportional of all of them. So A and G, those angles match up, so we're going to look at the side length between AG and BH, and if they're proportional to the next side over, which is BC and HI, make sure it's similar to CD over IJ, and AD over GJ, then these two figures are going to be similar. And look, you can see the notation here. All right, so let's do an actual example. So this says that these two figures are in fact congruent. There's a little marking here. It says list all congruent angles and write the proportional related to the sides. Okay, so if you look here, J is going to relate to P. So I'm going to just mark it on here and mark it down here. J is congruent to P. Remember, your angles are still congruent. L and M are going to be my next ones. And then my last ones are going to be K and N. So all of my angles are still going to be congruent, but now let's look at the sides. So to do a proportional statement, you got to relate all the sides. So let's start with JL and MP. Okay, that needs to be equal to the next one, which is going to be LK and MN. Oop. Sorry, this one should be MP. This one's MN. And lastly, JK and PN. All right. Notice that the smaller triangle is always going to be across the top. So all of those side lengths have to deal with the triangle that's to the left, and all of the bottom ones are dealing with the triangle that's to the right. So if you need to, left, right. All right. So as long as all of these are equal to each other, then these two triangles are similar. All right. Scale factor. A scale factor is a ratio of corresponding linear measurements of two similar figures. It is also called the ratio of corresponding sides. So this is what we've been talking about thus far. Okay, so the scale factor of ABC to XYZ is 5 to 2. You can also say the scale factor of XYZ to ABC is 2 to 5. So that means if you look at each of the ratios of all the sides, notice that they're all 5 halves or 5 to 2. And we say 5 to 2 because the triangle to the left is across the top and the triangle to the right is across the bottom. This is where your math frac might come in helpful on your exam. Where your math frac button might come in handy, because you're going to have to reduce all of your fractions, but your math frac button will do that for you. So let's look at this example here. It says, are these polygons similar? If they are, write a similarity statement and give a scale factor. So I'm going to highlight the corresponding sides. So 6 to 6, 12 to 6, 16 to 24, and 14 to 24. All right. So I'm going to write all of my, all of my ratios. So I have 6 over 6, 12 over 6, 24 over 16, and 24 over 14. Okay, well 6 over 6, if you math bracket, that'll give you 1. 12 over 6 will give you 2. 24 over 16, 12 over 8, 6 over 4, which is 3 over 2. So you should get 3 over 2 in your calculator. 24 over 14 would be 12 over 7. So if you look at all of these, you'll notice that none of these ratios are the same. Therefore, these are not similar. So you would write not similar. I could have easily seen in the beginning with this 6 and 6, that would have been 1, and I noticed that 12 over 6 was 2. You should check all of your sides anyway, just to make sure that that's not the case. Okay? This one is going to be saying, all right, we do know that these are similar and they have a scale factor of 2 to 3. So that means 2 to 3 should be the ratio. Find the value of x. It says use scale factor ratios to write a proportional statement. So you're going to write 2 over 3, and then our left triangle is the 2 to 3. 2 is going to correspond to 42, and 3 is going to correspond to x. Okay? Now, this is really simple. This is just going to be a ratio that you're going to solve like we did yesterday through cross multiplication. So we're going to get 2x equals 42 times 3. 2x equals 126. Divide by 2. X equals 63. Now, how I can check this, because we're always worried about how we can check, is put 42 over 63 and go ahead and math bracket to make sure that we get a ratio of 2 over 3, which you will if you do that. So you're going to set up a proportion, solve for x, and then check it using your math frac function in your calculator. All right. The next example here is dealing with scale drawings. So these are things like maps or kind of like legends that you would use. So obviously, if you look down here, the Golden Gate Bridge is not that small. It's a smaller depiction of it, but it is similar. So it says the diagram shows a scale drawing of the Golden Gate Bridge. The distance between the two towers, if the main the distance between the two towers if the main span. So it's saying down here, if you look at the scale, 1 centimeter equals 200 meters. What is the actual length of the main span? Okay. So it says that the drawing is 6.4 centimeters. So we know that 1 centimeter, let me find a color that is visible. 1 centimeter is equal to 200 actual meters. And we know the drawing is 6.4 centimeters. So what is the actual length of the Golden Gate Bridge? So just like we did yesterday, we're going to solve this using a proportion. So 1 times x equals 6.4 times 200. So we get x equals, and then 1280. So it's 1,280 280, please make sure you use your units of measurement, so that's meters. So same thing that we did before, setting up with a ratio and solving for x. So the Golden Gate Bridge is about 1,200, 1,300 meters long. And remember, there are 3 feet in a meter, so you can kind of guesstimate that. All right. The last sort of thing we're going to be looking at is perimeter. So you can actually determine if 2 polygons are similar based on just their perimeters. So if you add up all the side lengths, and the ratio of the one to the left is equal to the one to the right, then you know that these two are similar. So if you look at the example there, if KLMN is similar to PQRS, then the perimeter of the one on the left is proportional to the one on the right. So then each piece is also going to be proportional to each other. But let's look at an example. So it says, are these polygons similar? If they are, write a similarity statement and give a scale factor. Okay. It says match up corresponding sides and angles first, then check proportions. So I'm going to match up all of my sides. So if you look here, C is congruent to F, and A is congruent to D. So the side length is going to be 8 over 10. So that's going to be our first one. Okay. Then you can look at the next one will be between D and E and C and B. So it's going to be 16 over 15. I'm just going to put a question mark here because we don't know yet. The last one's going to be 12 over 20. All right. I'm going to simplify all of these. So I get 4/5 here. Those actually don't simplify anymore. And we get 6 over 10. Which is the same as 3 over 5. So if you look, we get 4/5, 16/15, and 3/5. So these two figures are not similar. All right, so we set up all the ratios, and we found out that these two shapes are not similar. All right. The next ones from 10 all the way to 17 are easy practices for you to do. Be sure to read the directions because some of them ask, like on 13, to find the perimeter. Some of them are asking you to solve for x. And some of them are asking for scale factor. Okay? So make sure that you're reading the directions clearly.